Okay, good afternoon to everybody. Myself, PK Wakankar, SSC Signal from Chemtech Gwalior. On behalf of Chemtech, I welcome all the participants in this webinar on multi-section digital access counter by Medha, that is model MAC181. I also welcome Mr. Ashirwad Prasad Acharya and Mr. Puttaraju, who will be given the presentation on the subject. During the webinar, I request all of you to please keep your mics mute. Please keep your mics mute during the presentation. Only if you want to ask the question, then only you should keep your mic unmute. So, without wasting any time, I request Mr. Acharya Ashirwad to start his presentation.
Thank you very much, sir. So, good afternoon to one and all. I'm Ashirwad Acharya. Along with me, Mr. Raju is available here. So, we'll have a discussion about Medha system. I hope the slide is visible to everyone. So, if in case there is some problem with the sharing of files, or you are not you are not synced with the words that I am saying along with the slide, please do let me know, because I have from my past experience, I have faced that there is some problem while moving the slides. So better we'll start as of now. So I hope you might have heard about the working principle of multiple section digital Excel counter. So today we'll discuss about Medha make. So the code of the system is MAC 181. So this is basically for multi-section. The Excel counter is built and the RDSO specification as mentioned below. So basically, the system will be a combination of few subsystems, subunits. So let's know first what are the subunits that we have. The MSc 181 system consists of a processing or the decision making subunit, which is central evaluator unit, that is CEU. And in order to deal with field information, we'll be having DACFU, which is Digital Excel Counter Field Unit. Along with that, Excel's detectors will be there. In SM room, we do have two options. One of the option is reset panel. The other option is VDU. Either one of them should be used, or if required, both also can be used as an option for the SM. So apart from that, line verification box, a relay unit, and in order to troubleshoot or find out the fault analysis to be done, so for that DT or diagnostic terminal will be provided, and this for Medha make. So here you can see the system architecture. So as a system architecture, clearly you can see in the block diagram, our system is designed to take.
Sir, your first screen is visible only.
Okay, that's the problem. I normally face this problem while.
Now it is visible, but sir, your full screen is not visible. You can make it full screen.
No, I'm going for full screen only. Let's go once again. Just a minute. I'll share it again.
Okay.
Now it is visible.
Sir, it is visible, but it is not in the full screen mode. You can make it from slideshow, I think. On the top of the menu, there is slideshow.
No, normally I go for slide. Okay, just a minute.
Slideshow from.
This is helping. Now it is visible.
No, actually it is visible, but it is not.
No, I'm asking about the full screen. Whether the full screen is visible or not.
No, actually now it is third screen now. You have
No,
moved
third
that?
screen, but it's the full screen, no?
No, sir, not a full screen.
पूरी
It is
स्क्रीन दिखाई, हेलो सर, सर पूरी स्क्रीन दिखाई दे रही है, लेकिन वो
नहीं सर, इसका जो मोड है ना, स्लाइड शो में जाके आप करेंगे ना तो हो जाएगा वो।
नहीं, स्लाइड शो में ही कर रहे हैं सर।
अच्छा,
लेट मी डू इट अगेन।
ओके।
यहाँ पे F5 अभी
No, it is not a slideshow. Please press F5. Then slideshow. Then presentation will start in the form
no,
of slides.
I went for F5 as well. Now it is visible.
It's visible.
Just a minute, please be in line. I'll go from the beginning again. I hope it is visible as of now.
No, it is not yet. Not
The
yet.
same problem still there.
Not visible.
Okay, we'll do one thing. I'll go for
Sir, if there is any problem, you can share with me, so I will share from here.
okay. I went for the PDF option. Now it is visible.
No, not yet visible. अभी load नहीं हुआ शायद वो।
Just a minute. Okay.
हाँ, now
Now?
now it is visible.
Okay, fine.
Now it is better.
Okay, fine. We'll go for this. So as we were discussing, the Medha equipment, it consists of will assemble a few subsystems. So the first subsystem is central evaluator unit, visually placed in the relay room, which deals with all the decision making activities. And in order to get the field information, we'll be providing a unit that is digital Excel counter field unit that might be placed in the location box, or we call it as mushroom box. Then in order to get the information, we'll be using sensors. So the sensors, we call it as Excel detectors. In SM room, basically two options will be provided. One of the option is your reset panel, and the other option is VDU. So as per the requirement, either one of them can be used or both of them can be used. Then line verification box will be provided in order to give information for like line verification key can be used for manual inspection, and reset can be given. Then a relay unit for the for placing the relays that we will be using, and for failure diagnostic will be providing DT or diagnostic terminal. So these are the subsystems that combine together to form the MAC181 system.
So this video unit is separate, or it is used in the existing video?
The video can be used in existing as well, because we do have a provision to provide reset panel in the SM room. But if the yard is a bigger one, so in general they prefer for video. So both options are possible.
No, actually, video means that EI video or a separate video for
No,
Excel
a
counter.
separate video will be provided. EI video has nothing to do with MSc 181.
Okay.
Sir, because MSc 181 will be dealing with only the reset options, the status of the system. These all things will be provided in the video. And EI video is a different one, and this one will be a different one.
Okay.
Okay. Then when we see the system architecture, we can see here the number of Excel detector, the maximum capacity of the system that it can handle is, it can take care of 40 sensors, that is 40 DAC FU unit, and 39 track section can be taken care by the system. So this is the maximum capacity of a single unit of CEU, that it can handle 39 track section and 40 detection point, that is access counter. So here you can see, so basically 40 DSFE unit, and the CEU will be connecting with the diagnostic terminal for maintenance purpose. Again, it will be connected with the VDU, line verification box, reset panel. If required, the EI is Medha EI. So Medha EI can be directly connected with the MAC181 system. Or if in case other EI is there, then a relay unit is required. So this is the system architecture, how the system connects and how the information is collected from one system to other system. So maximum number of sensors or DSFU is 40 as discussed earlier. So the system, that is MAC181, is designed and can support different type of configuration. So the configuration that it is supporting as of now is 1DP1S, that is one detection point single section, basically for sidings and all. 2 detection point single section, that is for block section or in a straight line. 3 detection point single section, that is for point section. And maximum, if there are n number of points, so multiple detection point also the system can handle, maximum up to 8. So these are the different configuration that the system is designed to support. Then discussing about the working voltage and technical aspect of the system. The input voltage of the system or the working voltage of the system is 24 volt DC with a cycle time of 222 millisecond, and the communication data transfer rate is 1 Mbps, and the system is designed to work from a temperature variation from -10 degree to +70 degree centigrade. So these are the technical features of the system. Then when we discuss about the first subsystem unit, that is central evaluator unit, this unit is designed as per the architecture, that is 2 out of 3 architecture with identical hardware and software. So as 2 out of 3 architecture, the minimum requirement of the system is 2 of the processor card. If it gives the proper output, then the system will drive the output. So the system is working on 2 out of 3 architecture, basically the central evaluator unit. The job of central evaluator unit is to receive the track section information and to receive the reset command that is given by the station master through panel or VDU. It will evaluate the track section status and it will get the information of the wheel count as per the configuration that is provided. All the driving of the relays that is available in the central evaluator unit, whether the track section is occupied or the track section is free, that all information will be provided to the station master through the central evaluator unit. Basically, we can say that whatever information that we are receiving from the field or from the sensors through DSFE unit, that information will be collected by the central evaluator unit, and same information will be provided to station master and to the DT or diagnostic terminal. Then this is the front fascia of central evaluator unit or the front fascia of the CEU. So here you can see this front system consists of different types of card along with processor card, power supply card, and as per the different type of communication, different cards are provided, and it do have a section for the relays and for communication. We'll discuss about every card that we use. So as discussed earlier, it do have a capacity to handle 39 track section or 40 field unit sensor, that is DSFE unit. So as the system works in 2 out of 3 architecture, so the first we need to see what are the card we are using. We'll discuss about the card first, then we'll discuss about the different type of working. So the first card we'll discuss about is Central Evaluator Unit card, that is CEC. So the CEC is a 32-bit processor card, and as it works on 2 out of 3 architecture, so as the card work on 2 out of 3 architecture, this consists of 3 processor, which is 32-bit. So along with this 32-bit processor, we will be having individual input card. So let's see the input card first. The input card is known as VIC in our system, that is vital input card. And each vital input card is designed to take care maximum 32 inputs. So as it is designed to take care of 32 inputs, so what are the inputs that we need to discuss? We'll see that. The inputs are 39 track sections, and each track section there will be some common bit. The common bit is reset, line verification, and the particular relay readback. So likewise, every relay will have these 3 bit as common. So as the maximum number of track section is 39, so 39 into 3, which is a common bit for every relay, the total number of input will be 117 input that will come from the field. Apart from this 117 inputs, there will be some system inputs, that is NONC, that is for the key in, that is for key NO and key NC. One common input from the system will be buzzer, and one of them will be spare. So in total, the number of input will be 121. So as the vital input card capacity is, it can handle 32 bit. So 32 bit is the maximum capacity, and our number of input from the field is 121. So we need 4 vital input card in order to give information of maximum information from the field. So likewise, for a single processor card, 4 vital input card will be required. As the system works as 2 out of 3 architecture, we will be provided with 3 processor card. So for each processor card, 4 vital input card is required. So in total, 12 VIC card is required in the system. I hope this is clear. So basically what will happen is, we will be working on the principle of 2 out of 3 architecture. On that concept, 3 processor will be there, and number of field input that will be coming is 121 in general, and a single card capacity is 32. So in order to go for the maximum input, 4 vital input card can be taken care by the system. And as each information need to be provided to every processor, so in total, as per the requirement, 12 VIC card will be used. So here you can see the diagram. So we will be provided with 3 processors, that is CEC-A, CEC-B, and CEC-C, and each processor will be taking care or will be getting information from 4 vital input card. So likewise, in total, 12 vital input card will be required by the system. Next, discussing about vital output card. So as the number of track section is 39. So we'll be having vital output card in order to drive the relay, and a single vital output card can drive 10 relays. So as per the requirement, 4 card will be used as vital output card. So 12 vital input card and 4 vital output card is the capacity of the system. Then there will be one more card, that is NVOC, that is non-vital output card, that will deal with all the non-vital activities such as whether the section is clear or occupied indications, whether PR relay is picked up or not, that indication, and reset counter indication. So basically, the non-vital card will get this all information. So for every track circuit, whether that track circuit is clear, occupied, preparatory is given or not, or reset is done or not, for that, these 4 bits are common for all the 39 track section. Likewise, for all the 4 track section, 39 into 4, 156 bit is required. And the single capacity of a non-vital output card is 84 output can be taken care by the non-vital card. Likewise, apart from this 156 bit, there will be some common non-vital output as well. The common non-vital output is system health indication, wrong side failure indication, track section faulty indication, and system mode. Apart from that, buzzer and 3 spares. So in total, our system will get total number of bit is 156 from 39 track circuit and 8 as the common bit. So in total, there will be 164 bits. Out of this 164 bit, as a single non-vital output card can handle 84. So in general, 2 non-vital output card is required. So here the conclusion is the processor card, as it follows 2 out of 3 architecture, there will be 3 processor card. With respect to input, there will be 4 input card for an individual processor. So in total, 12 input card. In order to drive the relay, 4 output card will be required. And for non-vital output, 2 will be required as per the system capacity. Then we'll have one more card, that is data interface card, which will be communicating with the data logger as well as diagnostic terminal. So this system will have a capacity of 8 MB, out of which 40,000 events can be stored. Out of this 8 MB, 2 MB dedicated for data logger and 6 MB is dedicated for DT or diagnostic terminal. And the communication between DT and DIC means diagnostic terminal and data interface CPU is through OFC, and this is the speed, that is 230-400 bps is the speed of the system. Then discussing about the type of communication, there will be 2 types of method that can be used for communication. So depending on the type of communication between central evaluator and the field unit. So we need to communicate the field unit system with the relay room system. So basically 2 types are used. One of them is quad cable communication. The other option is optical fiber cable communication. So depending on the type of communication, 2 different card will be used. If the communication between central evaluator CPU and field unit, that is DACFU, is through quad cable, we'll be using CE CMC, that is central evaluator modern CPU card. And if the mode of communication is through OFC, we'll be using central evaluator OFC card. So likewise, depending on the type of communication, two different card will be or can be used. And a single CEMC or COFC card can handle or take care of 8 DSFE unit. So as the number of DSFE unit is 40, so maximum we can go up to 5 CEMC, that is quad cable, or 5 COFC card as per the requirement of the site. Then discussing about the type of power supply card, basically two type of power supply card are housed in the central evaluator. One of them is PSA, that is power supply type A. One of them is PSB, that is power supply type B. The input to both the power supply card is 24 volt DC, and as per the requirement, the output is 4.5 at the rate of 8 ampere, and power supply B output is 5.6 volt at the rate of 2 ampere. So power supply type A will be used by input card, output card, non-vital output card, the processor, and CEMC card, while power supply B will be used by the DIC or CEC power manager will be using the power supply B type. For communication, we'll be using OFC. We'll discuss about this. So this is the conclusion, like how many unit or how many cards are provided in the central evaluator unit. As discussed earlier, the number of processor will be 3, following the 2 out of 3 architecture. The number of input VIC is 12, output is maximum 4, non-vital 2, data interface card will be 1, that will give information to data logger as well as DT. Then if the mode of communication is quad communication, we'll go for CEMC card, and maximum 5 can be used. Same like OFC 5, 2 power supply card for channel A and channel B. And the communication will be through OFC converter, and maximum 8 number can be used. So this is the front fascia, how the central evaluator look like. So here you can see CEC-A, CEC-B, and CEC-C. These are the 3 processors and vital input card for processor A, processor B, and processor C1. A 234, B 234, and C 234. Likewise, DIC card is there, 2 power supply card, and CEMC for quad communication, and the same will be replaced by COFC for OFC communication. That will be the only changes in the central evaluator as per the communication. So the only card that will change is the COFC or CEMC as per the type of communication that we will be using. Then discussing about the field unit. The field unit, we called it as DACFU, that is digital axial counter field unit, and this will be placed in the location box or it will be placed in the mushroom box I discussed earlier. So it acts as a interface between the central evaluator and the sensors or axial detector. So this particular unit will work on the architecture of 2 out of 2 architecture. So here you can make the difference. The central evaluator unit works on 2 out of 3 architecture, and the field unit, that is digital axial counter, works on the architecture of 2 out of 2 architecture with same hardware and same software. In this digital axial counter, as the sensors bit will be collected, so basically 2 types of sensors we are using for 181, that is MSC 181. The 2 types of sensors are working on 31 kilohertz and 36 kilohertz. So as per the type of sensor, this particular DSFE unit will have CPU card to collect the information from each sensor. For 31 kilohertz, one CPU card will be there, and for 36 kilohertz, one CPU card will be there. So here you can see in the picture how the system looks like. So as there are two sensors, so there will be two cards, one for 31 and one for 36. And this is the processing card that will process the information and will give the information to the central evaluator. For the two sensors, two cards will be provided. So these are the cards that is available in the DSC-FU unit. Two control card, that is DCC 31 and DCC 36. One modem card will be there, again depending on the type of communication. If the mode of communication is quad, the modem card will be DMC. If the mode of communication is OFC, the same card will be replaced by DOFC. So this is the only change that will happen if in case the mode of communication is changed from quad to OFC. Rest, everything remains the same. So it can be placed in two locations as discussed earlier, in the mushroom box or in the location box. So when we are going for quad communication, the communication is done as per the diagram given, and basically it will be in the form of star communication. So likewise, in total 40 sensors can be connected to the central evaluator unit. But here there will be no ring configuration that generally we use for OFC, but in quad it will be star mode of communication. Likewise, when we go for OFC mode of communication, ring configuration can be achieved here. So basically, 8 DSFU unit can be combined together to form a ring. So as the number of DPs that the system can handle is 40, so 5 independent ring channels can be prepared or can be done for communications. So here you can see in the diagram how the communication is done. So basically, every 8 DSFE unit forms a ring, and there will be a primary communication followed by a secondary communication, and it forms a ring. So likewise, 8 sensors combine together to form a ring, and we can go up to maximum 5 ring by using OFC as the mode of communication. So here, this is the pictorial diagram, how the communication is established between 8 sensors and again forming a ring and giving the information to the central evaluator. Then discussing about the detectors or sensors, I discussed earlier, there will be two pair of TX and RX coil, which will be working on different frequency. One of the frequency is 31 kilohertz. The other frequency is 36 kilohertz, which will be used to detect the presence of wheel on the basis of phase difference. So accordingly, as per the requirement, there will be two coils, one for transmitting, the other for receiving, to detect the wheel count by the change in phase and wheel presence by the change in amplitude of the particular position of the wheel. Okay, then the axial detector is designed to work for all the above diameter that is accepted in Indian Railways. Then this is the sensors I was discussing about. So there are two sensors, that is one of them is 31, the other one is 36 kilohertz frequency. So this is about the field unit. Then in SM room, we'll be providing a reset panel, and the reset panel will have a provision to give information regarding all the 39 track section status, whether the particular section is occupied or free. And apart from that, reset option will be independently provided for each 39 section. Then a common key will be provided, that is SM, power, OK, system failure indication, and buzzers are also provided in reset panel. So these are the reset panel information, that is SM key, power OK, health indication, system mode indication, wrong side failure, track section is occupied, sorry, faulty indication, buzzers. This all information is provided. So this is the pictorial of the reset. You can see here for every individual section, the option is provided with whether that particular section preparatory is applied or not, how many times reset is applied. For every reset button will be provided, and section is occupied or clear. Information is divided as per the number of track sections. And these are the few common reset information. Then the other option, as discussed, reset panel can be replaced by VDU, which is a software-based application system, same like in EI, which will be provided with a SM key, which is password protected, and all the function that we can achieve through reset panel can be achieved by the click of the mouse. The only difference is their manual or physical button will be there. Here, the same thing will be done by using mouse. So this unit will be provided in the SM room. The next subsystem is line verification box, which will be used to reset after a verification is done. So basically this will be used for after manual verification in order to reset the particular track section. So this line verification box along with the key will be provided to go for manual reset. Then in order to deal with the events, whether the track section is occupied or the section wise information, in order to get information about the fault with respect to the system or communication, DT or diagnostic terminal will be provided in the maintenance room so that the failure and all can be checked. So DT is designed, or it's a PC based application which will store the data, and the same can be downloaded for further troubleshooting or analysis point of view. So this is how the DT or diagnostic terminal look like, which will give information of every track circuit, whether it is occupied, free, whether the section is healthy or communication is healthy, how many in count and out count, and with respect to the system side, if in case any failure is there, the same failure can be provided in the fault section as well. So DT or diagnostic terminal is a part of failure analysis and troubleshooting. Then discussing about the number of relays that we have. The number of relays as per the number of track section. So basically 39, for 39 track section, 39 relays will be there. And normally the relay that we use is QN1 relay of 6F and 6B configuration. So this unit will be provided in the central evaluator itself. And next is about the power supply. So basically these are the working input to the system is 24 volt DC, and these are the different range on which the system will work. That is 19.2 to 28 working voltage. Then reset panel is again 92.28. For VDU PC will be using embedded one, so there 24 volt DC is required. Then for DT we can use the normal PC which works on 230 volt. And discussing about outdoor equipment, the detection point and all will get a voltage variation from 16.8 to 66, and for line verification, same the range will be 19.2 to 28.8 volt DC. So these are the different type of subsystem in our MAC181. I hope this is clear, and this is the data about the installation till date. It's not updated one. I think last 2 months back it was updated. So these are the details of the type of installation that we have covered till date. So this is from my end, and if in case any queries is there, please do let me know, or else regarding the field, how the installation is done for the auto section and all, that will be covered by Mr. Raju. He will take over from here. If in case any doubt is there, please do let me know, or else I'll hand over to Mr. Raju.
Sir, in which railway it is presently installed, this MS deck?
As of now, SCR, East Coast, Northern Railway, NCR, SECR.
Sir, NCR, can you give the station name?
Okay, I'll hand over to Mr. Raju. He'll give you the complete information.
Okay, okay.
Okay, please, Raju.
Sir, anybody, if you want to ask the question, you can ask. If any doubts are there, you can clear them.
Please, any doubt is there, so we can.
I think you can proceed for next part if there are any
Okay,
doubts.
fine. We'll discuss about how the installation is done for a auto section that we have already commissioned. Mr. Raju will explain that. After that, if in case any doubt is there, we'll proceed further.
Auto section with quadrupole line in South Central Railway between Maulali to Petkesar auto section. This is quadrupole line in that 4 lanes section. This is here. This is the how DPs are segregated and how DPs are allocated with their address. Normally, our system capacity is 40 DPs. For that, we need to provide DP address individually. That should not repeat like that. Whatever the DP address we are given, that should not repeat again. Means that continuously up to 40, we have to give different address to DPs. Like that, we are given separate DP address to individual DPs, and we and this is the straight line. So we are configured this section with 2 DP 1S configuration. Means that instead of in one track section, we are configured 2 DPs. One is entry DP, another one is exit DP. This complete auto section is configured with 2 DP 1S. Like that, we are configured in individual track sections. Along with, we provided supervisory track sections also. Each two track section, we provided one supervisory track section. Supervisory track section helps normal track sections for resetting purpose. Normally, in auto section, we provided dual detection. For dual detection, dual track sections are also available. In case one track section fails, it will take auto reset with redundancy track section. In case both main and dual track section fails, it will take auto reset with the supervisory track section. Manual reset is applicable only for both main and dual track section and SPT fail condition only. Other than it will take auto reset when main to dual or SPT. This is the configuration we have done in auto section. And this is the cable coverage plan, how we are laid cable from DPs to evaluator, and how we transferred station DPs to station DPs information to evaluator, which is placed in auto Gumti. Normally in auto section, we are provided central evaluator in central Gumti only. All DP information will bring which are near to auto Gumti through quad cable, and which are DPs are remote from auto Gumti, means that which are located in station, we are bring that information to quad to OFC converters. This is the cable coverage plan, how we are connected individual DPs to evaluators. For main and dual, we are provided separate 6 quad cables.
So here each detection point is dual detection.
Yeah, each track section having dual detections.
Okay.
That was the special requirement of the customers.
And this is the track section configuration, how we are track sections are configuration in each and every evaluators. These are the DP numbers and these are the track sections. Main track sections, dual track sections, and their expected supervisory track sections. These are the track sections, these are the DPs. For here, separate we are provided evaluator first, main individually and dual individually. Both are
Sir,
working.
what is the longest possible distance you can connect a DP? What is the possible distance?
From DP or
From your evaluator.
from evaluator to DP, madam.
Yes.
Yeah, now it is working up to 3 kilometers, madam.
Up to 3 kilometers.
Yeah,
okay.
yeah, with power. If you provide power supply near to DP, the communication we can carry out up to 15 kilometers from evaluator to DP. If possible to provide DP power supply in local.
Okay. The possible communication is 3 kilometers.
Yeah, with power.
Yes.
Sir, here it is how we are applying reset from station to for this block section. Normally in auto section, we will provide central evaluator in auto Gumti, along with we will provide their reset panel, sir. But this is auto section. We want to apply reset for this section, means we will provide one global reset box at the sending station master, and we will provide one line verification box at the receiving station master. In case if any track section in between auto section was failed, the station master wants to apply reset for that track section. First, receiving station master will give line verification, because they want to verify that complete arrival of train or not. After applying of line verification by receiving station master, sending station master global reset box having one LV indication. That indication will glow, sir. After that indication, sending station master will give reset, like they press SM key and push button. The three inputs system will take and system will apply reset which track section was faulty. This is the resetting procedure in auto section. This is the installation procedure in auto section, madam.
Praveer sir,
Yes, please.
we are here to take up the questions. Any doubt is there, then we are open to answer the questions.
Okay, okay. So, if anybody want to ask question, please, them ask. Sir, here that from evaluator to DP, anything that OFC can be used, na?
Yes, sir, we do have both option, OFC as well as quad, both can be used. As per the requirement, we will be providing quad communication, then there will be a different card, that is CEMC card. And
Yes,
if it is
yes.
OFC, there will be different card.
Yes, okay. किसी को कोई क्वेश्चन पूछना चाहते हैं तो पूछ सकते हैं.
हाँ, कोई डाउट है तो पूछ लीजिए, हम लोग ट्राई करेंगे डाउट क्लियर करने के लिए.
सर नमस्ते सर.
नमस्ते सर.
हाँ, पूछिए पूछिए.
हेलो सर, सीनियर टेक का इंक्लूड सर बिजवाड़ा डिवीजन साउथ
सर.
सेंट्रल पे.
ओके सर.
हेलो सर, आवाज आ रही है?
हाँ सर, सर बोलिए सर.
सर ये लाइन वेरिफिकेशन करने के बाद ये ग्लोबल रीसेट जो करते हैं, नंबर चेंज होता है उस समय सम टाइम रीसेट नहीं हुआ तो फिर कैसे मालूम चलेगा सर? कुछ इंडिकेशन स्टडी नहीं रहता है कि रीसेट मोड में है सर. ऐसा एक बार हो चुका है हमारे सेक्शन में. नंबर चेंज हुआ सर, लेकिन रीसेट मोड नहीं आया. फिर सेकंड टाइम करना पड़ा. डीटी देखने के बाद मालूम चला कि वो रीसेट मोड नहीं लिया. उस कंडीशन में क्या करेंगे सर, अगर सपोज डीटी नहीं देख पाए तो?
सर डीटी देखना ही पड़ेगा सर, क्योंकि वो आईबी सेक्शन है ना सर, आईबी इंस्टॉलेशन है सर.
Sir, he's saying that if at all, both the station masters are to apply this line verification and reset at one end, and both the station master are not aware of the DT. So some indication should be provided with the station master so that the other person has pressed a line verification or it has went into reset mode. So need not be trying for other reset, need not apply reset many times like that. Some indication, something should be told.
No, madam. Actually, in
So we are facing that problem here.
Actually, in global reset box, we are not provided any preparatory indication, madam. Whatever the preparatory and occupied clear indications are there, that will be in manual, but whatever this main reset box, madam. This is this global reset box we are provided for global reset only, madam. That information
Globally said, but master should have, both the station masters should not wait for ESM to come and give the information, right? The master should immediately apply for global reset if they have any trouble. They should not wait for ESM, or ESM should actually go to the IB hut or check for the reset reset panel. That's what we want to convey. And the other thing is, we want, do we have any such kind of reset errors? Like error, do we have any error codes?
Yeah, we are having that troubleshooting manual, madam. In that, all error codes and faulty status and descriptions is available, madam.
Okay, okay.
Yeah. For this, we will see the possibility, madam. Whatever you are requested, for this, we will see the possibilities.
Please look into.
Okay, ma'am.
Right.
It will be helpful for finding out the errors and all. All code details will be given there. We'll provide that. Any further queries?
Okay, any other question, please? Sir, can you share this PPT copy with us?
सर वन थिंग और प्रॉब्लम सर
Yes, प्लीज.
सर ये डीटी में सर एरर कोड नहीं रहता है सर, ये मशरूम बॉक्स में रहता है सर। रीसेट होने के बाद तो वो मालूम भी नहीं चलता है सर, तो डीटी में कैसे मालूम चलेगा सर वो एरर कोड हमको?
सर डीटी में सारी इवेंट्स एंड फॉल्ट स्टोर होता है सर। आप ऑफलाइन में जाके रिपोर्ट्स डाउनलोड करना पड़ेगा इसके लिए।
वो तो डाउनलोड हो जाती है सर, लेकिन एरर कोड के बारे में पूछ रहा है।
एरर कोड भी आएगा सर उसमें?
एरर कोड भी आएगा?
एरर कोड भी आएगा सर, सारी इंफॉर्मेशन आएगा आपको। टाइम, एरर कोड।
ऑफलाइन में जाने पर सर?
या ऑफलाइन। इवेंट डेटा में इवेंट डेटा में सारी इवेंट इंफॉर्मेशन आएगा और फॉल्ट डेटा में आपको एरर कोड आएगा, फॉल्ट डिस्क्रिप्शन भी आएगा सर।
ओके।
Sir, in NCR, in which section it is provided?
In NCR, we are commissioned in Kanpur local cabin and Juhiyad. Good sir.
Okay.
We'll provide Mr. Raja's number. In case आपको कोई field related doubt होता है, so आप उनको call करके field से ही call कर लीजिए, so that he'll help you with the queries and all. I'll share his number. Okay.
थोड़ा वॉइस थोड़ा कम आ रहा, आप कुछ बोला?
मैं वही बोल रहा हूँ सर कि I'll share Mr. Raju's number.
Yes,
In
please.
case those who are facing issues with the field activities,
Yes.
so you can directly call to him and he'll guide you.
Okay. You please share in the chat box, sir.
I'll do that.
Okay.
Okay, I have shared the number in the chat box. So again, I'll share this particular PPTs with.
Sir, you can share
Camtasia,
with me, so I will share with everyone.
I'll do that, sir. I'll
Yes, sir.
provide it to your mail ID, or I'll give you the link so that you can download from the Google link.
Okay, sir. Okay.
Okay, fine. I hope there is no further doubts. So
yes, sir. I think we can conclude.
Yeah,
And thanks to all the participants. And if still there is any doubt, so you have provided that shared the number, so we can ask. So thank you.
Okay, thank you very much for your patience. And
Okay,
here
thank
we
you.
conclude. Thank you for.
Thank you.